Good morning. Could somebody do me a favor, standing in the back, like shut the doors? And really, that's not a favor for me so much as it is a favor for those of you sitting in the back half of the room. I don't know about you, but it drives me crazy when I hear noise from the hallway. All right, so thank you for coming so early in the morning. You could use DateTime to figure out how little sleep you got, perhaps. So this is A Date with Perl. My name is Dave Rolsky. I work at Active State based out of Vancouver, and we're one of the sponsors of the conference. And this talk is going to be about dates and time concepts, and then I will show you some specific ways you can use DateTime and some specific gotchas with DateTime as well. So first thing you need to know is this stuff is just really, really crazy. There's a lot to deal with, and a lot of it doesn't make that much sense or is somewhat arbitrary. So there's different calendars, there's different time zones. We have daylight saving time, which is the stupidest thing in the world, completely freaking pointless. We have leap seconds. So if you take just one thing away from this talk, I want it to be this, okay? Don't write your own date and time manipulation code from scratch. There are libraries on CPAN, there's DateTime, there's other things like, what's it called, time moment. There's lots of things. Just use one of those. Do not try to do this from scratch like using local time and GM time. You will probably make a mistake if you're doing anything non-trivial. So please don't. So first concept we're going to talk about is the Gregorian Calendar, which is the calendar that we all generally live our lives by here in the US and most of the rest of the world. It's based just on the Earth's revolution around the sun. Whoa. Hello. Welcome to, oh. All right, Daytime Dave is back. All right. Yeah, my voice just changes when it gets dark and it's weird. Anyway, okay, so the Gregorian calendar, it's just based on the Earth's revolution around the sun, meaning it's just, it's not based on the moon as some other calendars are. This is the current world standard, and datetime.pm is based on the Gregorian calendar. And for most use cases, that's all you need. So, okay, I know hopefully most of you know this, but just gonna review some of the basics. It's 365 days in most years. We have leap years, which have an extra day. And this calendar is kind of, we say that it begins on January 1st, year one, which is written like this, even though it wasn't adopted till the late 1800s / early 1900s around the world. Year zero is also called 1 BC or 1 BCE. We might need to tweak the leap year algorithm, you know, in the near future. I'm sure all of us will be around to see this because the Earth's revolution around the sun is actually slowing. So maybe we'll need leap days a little more often or less often. We'll need them different. All right. So here's what using DateTime looks like in the kind of simplest form. We call the constructor new, we pass it different components, year, month, day, and then you can get information out of the object that you've made. So we can print out the date, and we can get the name of the month, and there's a lot of different information you can get. But we can also do this in French. Oh, ho, ho. So if we add a locale FR, that's saying we want the French language, and then we spit out the date. Now that's always the same, but if we spit out the month name, it gives us that in June. And there's actually a lot of information that is localized, things like what day is the start day of the week, the names of all the different things, and you can also get names. For example, you can get abbreviated names. And if you really dig in, you can get names that you might put in the table at the heading of a calendar, which could be just a single letter, things like that. So there's a huge amount of localized date and time information available through DateTime and the DateTime locale distribution. Of course, there are other calendars in the world that still matter for various things. In particular, there's a lot of holidays still celebrated around the world based on different calendars. For example, things like Easter. Pretty much every Jewish holiday is based on the Hebrew calendar. Chinese New Year is based, of course, on the Chinese calendar. Many of these calendars also, the reason that things move around in the Gregorian calendar, and we think it's moving around, they're not really moving around if you look at the other calendar. It's because these other calendars also factor in the lunar cycle or are solely based on the lunar cycle, which does not, it's not like there's exactly 12 lunar cycles per year, so that can throw things off, and that's why, for example, the Hebrew calendar has a leap month as well to kind of realign the calendar with the seasons. So the way you can do this, you have a date time that we've constructed, and then you can get a Chinese calendar object from the DateTime object, and you can also go the other way, and then of course you can get Chinese information about what the zodiac animal is, in case you were wondering. So on June 5th in 2013, which is probably when I first gave this talk, it was the year of the snake. All right, let's talk about times. So the day length, that's the one rotation of the Earth around its axis. You probably all know this. Day is 24 hours. In kind of DateTime's native speak, the first hour is hour 0, the last hour is 23. You can print these out in 12-hour time or various other formats. An hour is 60 minutes. Minutes are mostly 60 seconds, almost all the time. And then a day is mostly 86,400 seconds, most of the time. All right, a brief digression. Let's talk about atomic clocks. So with an atomic clock, there's like some physics crap that does a thing that like has atoms or something. I don't know. I have a music degree. I don't understand any of this stuff. It's just, it's magic. The idea is that with an atomic clock, we can tie the length of a second to kind of a physical constant that never changes. Rather than defining the length of a day by 86,400, we tie it to this much more low-level physical constant. And there's a standard called TAI, and that's the International Atomic Time Standard. But then there's this horrible thing called leap seconds, which makes date-time internals really confusing. So the problem is the Earth's rotation around its axis is actually slowing down. And eventually it's going to stop, and then one side of the planet's just going to like burst into flames, and the other side's going to freeze. And I'm really, really worried about this, because it could happen any day now. I think it's going to be in a few billion years or something, and it's kind of freaking me out. Anyway, so the Earth's rotation is slowing down, but we have now tied the length of a second to this physical constant that is not slowing down. So every once in a while, we need to resync our midnight, and there is a leap second introduced. And actually, the rate of the Earth's rotation slowing down is not really predictable. So in fact, these are only announced up to 6 months in advance. And so there's this organization, I forget who it is, that publishes a bulletin every 6 months or so saying whether or not there will be a leap second, and you just have to pay attention. So, okay, so we have our atomic clocks, we have TAI, we have leap seconds, then we have this thing called UTC, and this is hilarious to me. So in English, it's Coordinated Universal Time. In French, it's Temps Universel Coordonné. And so we agreed that the abbreviation should be UTC. I don't understand. Apparently, making nobody happy was the ideal compromise here. So, okay, anyway, so UTC is the TAI standard, the atomic time, plus the number of leap seconds so far, which is 37. And this is what is actually the current world standard. Most people are not using TAI time for anything. So if you have clocks that are, say, synced to an atomic clock, it's using the UTC standard. And this is based on the time in Greenwich, England for historical reasons. I don't know, the British won a wrestling match or something. So, and then we have time zones that are based on their offset from UTC, so like an hour earlier or an hour later. Time zones are terrible. They're just the worst. I really hate them. So they're political, which means, of course, they're really stupid, because politicians are, I mean, they just can't do anything right as far as I'm concerned. And they change all the time for really dumb reasons. There was a US time zone change back in, I don't remember, 2011 or I don't know, it's something. And it was nominally to save energy or something. It doesn't actually have any impact. It just makes programmers' lives hell. So Maybe it's, you know, make work for our industry and we shouldn't complain, but it's just really irritating. And in fact, if you think the US change was bad, some countries announce changes like a day in advance. Sometimes the changes get kind of made official before they're announced, and then people are scrambling to keep up with this. So the standard repository of all information about time zones is the IANA time zone database. And it used to be called the Olson time zone database, if any of you have heard that term. Arthur David Olson created it a long time ago, and then when he retired from his job, he gave it over to IANA to let them be the maintainers. Still sometimes called Olson. This is the homepage for it, and it's basically an open source data and software project. Of course, Microsoft does some random crap of their own, rather than following the standard that literally every other operating system uses. So here's what a time zone actually is. I mentioned it's an offset from UTC, and that's in minutes and hours. Some people think it's just hours. In fact, there are time zones that are, you know, X hours plus 30 minutes. There's also some time zones with 15-minute offsets. I don't know that there's anything more terrible than that. So here we are in Washington, D.C. I believe we're currently at 4 hours ahead of UTC. So if you take the UTC time, subtract 4 hours, that is the local time. So time zones also have a name. So it's not just the offset from UTC. And most of the names in the IANA database are a continent or an ocean, plus a major city. So we have America/Chicago, Asia/Taipei, Pacific/Fiji, that's an example of using the ocean. And sometimes they'll put in a third component if it's not, if it's gonna be ambiguous. So America, Argentina, San Juan, because I think there are multiple San Juans throughout the world and throughout America, so they have to add more stuff. So that's how you identify a time zone for real, is that long name. And then what the zone really is a collection of rules. And the rules define all of the DST changes that that zone has ever had historically and will have in the future. Because knowing the offset doesn't actually tell you that much. If all you care about is the current local time, then yes, the offset is sufficient. But if you want to know, for example, what something will be in 6 months, then you have to know what the rules are that define that zone. So for example, stupid countries like the US, where we have DST in most states, 6 months from now, we will have a different offset. And some sane countries, of course, in other parts of the world don't have DST, and they don't have this problem, so the rules are much simpler. The IANA database also has all these historical rules, so you can see kind of the history of time zone madness for about 100 plus years. And it goes back to kind of the late 1800s when time zones were first being adopted. And before that, it uses an offset that's effectively nonsense because it's just the local time of the city that's being named. But you know, Chicago had their own local time, and whatever another city is nearby, Skokie, had their own local time, and everybody was just basing it on where the sun was. The time zone database also has these short names that are defined, and they can vary based on whether daylight saving time is in effect or not. So CDT, CST, EDT, EST. It's really important to know that these names are not unique, and you cannot use them for identifying a time zone, but you can use them for displaying to end users. So for example, for a while, the Australian there was an Australian time zone that was also using EST and EDT, but it was plus 11 hours or something, whereas we're minus 4. So if you were trying to use that as a way to figure out the time zone from input or something like that, you would need additional information to make the guess. So what I recommend in your code is it's fine to use the short names for display, especially when you're displaying it to people, you know, in that time zone, because you're generally familiar with your own time zone short names, but they're not that useful for all time zones. Like I don't know the short names for all the European time zones, for example. So if you have to pick a time zone, this can be challenging. So this database includes a lot of historical time zones that are no longer relevant. For example, at one point, Chicago and Menominee, Wisconsin had different rules defining their DST transitions. I don't know why, But nowadays, and for quite some time, all of kind of the central US has followed along with the rules that are part of America Chicago. So if you look at the list of all zones, you get a lot of zones that aren't actually useful for people because they would, if you were giving them Menominee in Chicago and they picked one or the other, they'd get the same impact for current times and the future. So there's no API for finding the current time zones yet. That might be mistaken. Maybe somebody released something. I'll do some research. Anyway, just something to think about if you're creating some sort of web UI or something for people to select their time zone. You either want to find a way to select zones which are current through some automated system. I'm not sure how you do that. Or you might just need to curate the list. If you know all of the people using it are only US citizens, then you can pick from a list of 7 zones that apply to American states. All right, so one of the cool things you can do with time zones and DateTime, at least I think it's kind of cool, is you can construct a DateTime in a given time zone. So here we're constructing one in the America Chicago zone, and then you can set the time zone and figure out what time it is somewhere else, which is sometimes a question you may need to answer. So for example, we start with Chicago, we set it to Taipei, and then we get a new result. So there's this thing that DateTime implements called the floating time zone. And basically, it's the absence of a time zone. It's very philosophical. It's kind of, the mu answer. Is it mu or moo? I don't know. Anyway, so with the floating time zone, you effectively are saying, I don't have a time zone, I don't know, or I don't care. And I don't care is a very valid answer. And if you set a date time that's in the floating time zone to an actual time zone, it will not change the local time. Same going the other way. And it does not implement leap seconds, because leap seconds are tied to UTC. So you have to know your offset from UTC to know when a leap second is actually happening. But that's actually can be a really good thing. So here's an example. We make an object in the floating time zone, and then we set the time zone to Asia Taipei. I keep picking Taipei because my wife's Taiwanese and I love Taiwan. And the local time hasn't changed. So you see we print the date times out and they look exactly the same. Now if we were then to set it to America Chicago or something like that, we would change the local time and the date. All right, yet another concept, epochs. So you've probably all, or many of you have heard of the epoch. In fact, there are multiple epochs. An epoch's just like a reference point for the start of a date and time, for when a calendar starts. It's 0.0 on that calendar. So with the Gregorian calendar, that was year 1, month 1, day 1 at midnight. There's the Unix epoch, which starts on January 1st, 1970 at midnight UTC. That's important. It actually includes the time zone. And in Unix, the epoch is just counted in seconds. So, Unix epoch 10 was 10 seconds after that start time. It's not really UTC, even though it claims it's UTC, because POSIX actually specifies explicitly that we skip leap seconds. And this causes a funny thing. This is just great amusement. If you wait till the next leap second and just print out the time every second on your console, if you're synced to an atomic clock, you'll see 2 seconds in a row that are the same. Great excitement. You should all kind of set that up. It's like watching an eclipse, but on your computer with numbers. Super cool. So yeah, it's not quite UTC, but it's not really TIE because it does kind of account for the leap seconds. So yeah, it's a little weird. It doesn't matter for most cases. So if you want to know the epoch from a DateTime, it's really simple. There's a method called epoch, and it will spit out an appropriately large number. We're in the billions of leap seconds, the billions of seconds since the epoch currently. So there's a problem you might have heard of, which is fortunately becoming less of a problem. The Y2.038K problem is a lot less catchy than Y2K. So the problem is that the epoch will no longer fit in a 32-bit integer at a certain point, and that's exactly this date that's up here. And it actually can sneak up on you a lot sooner than you think. For example, if you're calculating a 30-year mortgage starting anytime in the past 9 years, you could have had this bite you. As of Perl 5.12, which hopefully, please tell me you're all using at least 5.12. No, don't tell me. I don't want to know. Okay. Perl internally uses a large enough epoch. It's not actually 64 bits in all cases. I think it's whatever the size of the IV is. But it's big enough that you won't have this problem and you will go way into the future before you overflow. And nowadays, it's rarer and rarer to find 32-bit systems. I certainly haven't used one in a while. So it's unlikely that this would hit you, but just something to keep in mind. So, DateTime ecosystem. There's a lot of stuff in this ecosystem besides datetime.pm and DateTime timezone and DateTime locale. Those are kind of the core 3 modules. We saw an example earlier with DateTime calendar Chinese. So there's modules that do formatting and parsing, and they're all under DateTime format, where read format as a noun, not a verb there. There's other calendars, which are all under DateTime calendar. There's modules for events and recurrences, which are typically under DateTime event. There's a couple others. And then there's like DateTime X stuff, which is just what I ask people to use if they have something that doesn't fit into this more rigid system. So there's a ton of stuff on CPAN. Take a look. And now I'm going to talk about some specific issues with the DateTime module that might bite you. So problem number 1. And by the way, I apologize for all this. I wrote this software back when I was young and full of vigor, starry-eyed, and very stupid. And if I had it to do all over again, I would do it very differently. But I don't have it to do all over again. I mean, I could write a DateTime 2 or whatever, but realistically, it's probably not worth the effort. Tons of people are using the existing one. Am I going to get them all to switch? I don't know. So probably you're going to have to deal with some of this stuff. So there's no date-only class. So the way you can work around this is if you use the floating time zone, then you don't have to deal with leap seconds, you don't have to deal with offsets from UTC, and you can do math that is date-only and have confidence that the results will be sane. And there's 2 math methods that I recommend. There's delta MD and delta days, which will give you the duration either in month and days or just in days between 2 dates. So you can use it like this. You make 2 date times, and you call it delta days. You get a date time duration back. That's part of the date time distribution. And then you ask for the days. And I'll explain this in units thing in a second. Now, if you used just the built-in overloading, you get the reason I recommend delta MD and delta days is that by default, the duration you get back will include all possible units. So seconds, minutes, days, and months. Those are the units that matter because minutes can be converted to hours, and days can be converted to weeks, and months can be converted to years. But you don't actually care about that, so you just want to know the difference in months and days or just the difference in days. So daytime duration, it does have a terrible API. The person who created it, just complete moron. I mean, if you see that guy at a conference, just smack him in the face. That's what I say. But fortunately, that guy doesn't exist. He's like, 15 years ago me, so you're going to have to go back in time to smack him in the face. So, joke's on you. So, like I said, internally it stores the duration, months, days, minutes, seconds, and nanoseconds. DateTime does support nanoseconds. And externally it has methods like years, months, weeks, days, and so on. But if you call the duration days, you'll just get the number of days, not the number of weeks. So if it's 1 week and 6 days, you'll get a 6 back, which is very confusing. But if you call in units, which is the API I should have written in the first place, you will get 13. So basically the takeaway is just use in units and you will probably get what you want. And the reason I haven't just changed this is I kind of realized this years after it had been released because people were like, I don't understand this API. They would do something exactly like this. They'd subtract, or, they do delta days one from the other, and they ask for the number of days, and it would give them 6, even though it should obviously be a much larger number. And they'd write me a bug report, and I'd be like, no, you just have to read the docs. And they're like, yeah, the docs are crazy, you're insane. Why does it work this way? So I added this in units thing so you could get something that's more useful. Again, it's not something I can really easily go back and change. So math is really hard with dates and times. Once you get time zones involved, once you get actual times involved, it gets really tricky. So I'm going to show you some gotchas just so you can think about them when you're writing your code. The problem is there's no fix. These are just inherent in the nature of the subject, and you just have to decide what the right answer is for your use cases. So question 1, how long is a month when you're doing math? So you might think, well, it's the length of the month I'm in. Okay, so we could do that. We could make a datetime that represents February 1st of 2009, a non-leap year. February is 28 days. We add 28 days, and we get the next month, March 1st. Then we add 28 days. And of course, we don't get the next month now because now we're in March, which has more days. So we get March 29th. Okay. But there's an easy workaround, right? Okay, so I'm going to add months instead of days, which is what I should have done in the first place. Okay, but now let's make it a little trickier. It's January 30th, 2009. Again, not a leap year. February has 28 days. So I add a month. And wait, what? I added a month and it's March 2nd? How does that make any sense? But then I add another month and it's April 2nd, which does make sense. So what's going on? The problem is there's different ways to add months. There's different modes. And again, this is not, finally, this isn't a mistake I made. This is just like a problem that exists with doing datetime math. Because every month has different lengths, when you add a month, it's not actually clear what should be done. So you have to tell it if you wanted to use a specific way of doing that. So there's these end of month modes. So the default when you add is to just wrap. So effectively what it's doing is figuring how many days are in the current month, and then adding that many days. There's also other methods where you can kind of not do that effectively. So if you use limit as our end of month mode, we add 1 month on January 30th, and what it basically limit says is don't go past the end of the next month. So it tries to add 30 days, goes, oh wait, I went 2 months ahead, and it kind of backs it up until it hits February 28th, and then if you add a month again, you will get March 28th. The difference between limit and preserve is with preserve, if it's the last day of the month, like say February 28th, and then you add a month, you'll get, I don't know how, okay, this is sad. I don't know how many days are in March, is it 30 or 31? 31, okay. We can all sing the song. If you use preserve and you add 1 month to February 28th, you get March 31st. So again, this is just a problem with the domain. You have to decide what you want to do. So how long is a day? This is another fun question. How many people think it's 24 hours? You're wrong. You should know everything's a trick question. Don't raise your hand. Okay. Mostly it's 24 hours, but because of daylight saving time, sometimes in some time zones, it's not. So for example, it is November 4th in 2012. It's a dark, wait, sorry, there's no story to go along with this. November 4th, 2012, in the America Chicago time zone at midnight. We add 1 hour and we get 1 a.m. We add 1 hour and somehow we get 3 a.m. Okay, that's because there is no 2 a.m. because the clock is jumping ahead 1 hour. So that particular day only happens to have 23 hours. And then we have the opposite problem. So it's March 11th, again, America, Chicago, a dark and stormy night. I was walking down the alley and added an hour. I don't know. I can't do a noir about daytime math or anything. It's just not going to be that exciting. She was wearing a wristwatch. Okay, so it's midnight, we add an hour, we get 1 o'clock, then we add an hour and we get 1 o'clock again. It's not quite the same 1 o'clock, but it's still 1 o'clock. So this day has 25 hours because the clock is jumping back. Again, more confusion. Oh, I think there's a mistake in this code. This should be. Oh, did I just do it backwards? Damn it. Okay, right, sorry. Anyway, you get the point. Sometimes there are 23-hour days. Sometimes there are 25-hour days. You cannot count on days being 24 hours unless you use the floating time zone. So again, I'm going to keep mentioning the floating time zone is a good way to avoid some of this pain. So there's this thing with the clock jumping ahead that we just talked about. What does that mean? Well, it means you don't get a 2 a.m. sometimes, and that can cause problems. So if we try to construct a date time for that non-existent time, we're going to have problems. So we're going to do it the day before at 2 a.m. And then what happens if we add a day? Well, you get an exception because we try to add a day, and then it looks, okay, the local time is 2 a.m. There is no 2 a.m., and all hell breaks loose. Now, I could have gone a different way and had it change the local time. And this, okay, you can somewhat blame me. This was my decision. That said, I will stand by this decision because I think it would be even more confusing if I had the local time changing when you added a day or a month and not a time component. However, if you add 24 hours, it will work, and you'll move the local time to 3 a.m. Again, kind of confusing, but I think also the correct way to think about it. So if you think about it, imagine there's kind of an old kind of analog clock that has one of those flip things where it flips the numbers. And so if we flip the day, then we end up with a bad local time because it still says 2 a.m. But if we flip the hours 24 times, then that would make sense because it would skip from 1 to 3. So that's kind of how I think about it in my head. I don't know if that helps anyone else. The order of math can also matter. So by default, DateTime has some weird order that was whatever was easiest when I was implementing this many years ago. It doesn't really matter what it is. I mean, in the sense that I could have picked some other order and it would not necessarily be better or worse. It would just cause different problems. It is documented what the order is. So if you just call add and you pass multiple units, it does whatever it does. So I think, yeah, for this example, if you pass months and days, it does days first. So it's February 28th, we add 1 day, we get March 1st, and then we add a month, we get April 1st. If it did it the other order, added the month first, we get March 28th, then we'd add a day and get March 29th. If you want to control the order, just make multiple calls to add. Again, this is documented and it's your decision to decide how to deal with this. There's even more math gotchas, and there's a bunch of these in the docs. Math is not always reversible when you're dealing with DST. So if you subtract one date time from another and you get the duration, and then you add the duration back to that date time, you might not get the original date time. If you do math across DST changes, it's very confusing. Are you supposed to include the extra hour if there was one? How do you deal with this? Again, the way this is handled is all documented, and I had to just kind of pick an arbitrary thing, like I'll do it this way. If you don't like it, generally there's a workaround. There's also leap years, which can affect date time math, leap seconds. So there are some ways to do this safely. Number one, always use add to add like days or months or whatever to a date time you have. I have seen people write code like this date time set, and then kind of manually do the math, and that is much more likely to expose you to weird bugs, and it's just wrong. There's a reason that there is an add method. There's subtraction methods like delta days and subtract, so conversely, do not do set with a subtraction. If you don't actually care about time zones, just use the floating time zone. It'll eliminate a huge number of these problems because a lot of them relate to leap seconds in DST. It won't eliminate that end of month issue, but it'll eliminate a lot of the others. And then the other option is consider using UTC when you do math. And in fact, at my last job, we had a subclass of datetime we used that overrode all the math methods and would internally convert to UTC, then do the math, and then convert back to the original time zone. And the reason for that was to avoid those exceptions I talked about when you say added a day and hit an invalid local time. So, but again, this is a decision you have to make because are you willing to accept the fact that your wall clock time is going to change in some cases because you're doing that. So those are my recommendations. If you can't do that, well, okay. There's also another issue with ambiguous local times to the constructor. So if we construct a time when it's one of those 25-hour days and we have two 1 a.m.s or two 2 a.m.s, whatever the time zone. Oh, by the way, there's some time zones that change at midnight, which really sucks, because if you try to construct a date time without passing in time components, it defaults to midnight. I think this is Egypt, so what the fuck, Egypt? Come on. They didn't look at my code before deciding their time zone rules? Actually, in all seriousness, it's not about my code. Changing at midnight's a bad idea. It makes everything really confusing. So when you construct an object that is ambiguous, DateTime is just going to pick the latest UTC time. That's, again, just a decision I made. There's no right or wrong answer. If you don't like this, you could construct it in UTC and then convert, or that's probably the best answer. There's no or. All right, some recommendations about storage and presentation. Whenever possible, store them as a floating time zone, again, if you don't really care about time zones, or store it in UTC. Don't just, the thing you cannot do is simply store whatever the local wall clock time is without any record of what the time zone was. So if you need to know the time zone of a DateTime that you're storing in a database or whatever, you must, ideally what you do is store it as like UTC plus a time zone or the local wall clock time plus a time zone. Postgres is not as good about this as it could be. Its timestamp with TZ type is actually kind of misnamed. It's really storing a UTC time plus an offset, which is not ideal. It does not store the full IANA name. So if you really, really need to know this stuff accurately, like if you're writing some sort of calendaring application that's like, if you were trying to write Google Calendar, you would have to store the UTC time or the local time plus the named offset so you can recreate things. Because, for example, if I have an appointment 2 years from now in some country that's constantly fiddling with its DST rules and it's at, noon, then if you just store it as UTC and then try to recreate it, if the time zone rules have changed, then you could end up with a mess. Question? Oh, yes. Yes. Yeah, he made a point. The Postgres timestamp with TZ is worse than I said. It doesn't store an offset. It's just when you do a select, like say in PSQL or in your app, it just uses whatever the configured time zone is for the connection, which I think by default with PSQL is the machine's local time zone, and just displays it that way. So yeah, it's very confusingly misnamed.
There's one exception, which is time with times and with times with TZ actually does store the offset.
Okay.
So you should do that kind of thing. You should create like a date column and a time with TZ, because time with TZ does store the offset.
Okay, so he said the time with TZ type does store the offset, so you could have separate date and time with TZ columns. Of course, as I pointed out, just storing the offset may not be sufficient anyway. I wouldn't be surprised if maybe there's a Postgres extension that handles some of this. I haven't looked. Another recommendation, don't store the epoch. It's kind of a similar problem of you're losing information. Store the date time. Use the time zones for presentation to users. So you store it in UTC, and then you know whatever your user has configured their local time zone to be, and you can present it to them that way. The worst thing you can do is just like use whatever the machine's local time zone is and store the wall clock time, because let's say you do that and then you decide to change your service time zones, or you move them to a different data center and they get changed for you, and then you're fetching them from the database, and suddenly it's just a huge mess. You really have to think. Here's the short version. Think real hard about how you're going to store this stuff, because it might bite you in the future. Don't just do whatever's easiest. Also, okay, finally, some performance tricks. And here are my rules of optimization, which I apply to all code all the time. I've had problems with coworkers who are like, well, why do you write it this really confusing way? Oh, it's faster. Did you benchmark it? Did you profile it? No, I just know it's faster. First of all, they might rewrite. I'm not actually disputing that it's faster. The point is, it doesn't matter if it's faster if the code is not in a hot path, only gets executed once every minute, and it takes an extra 5 milliseconds. So don't do these stupid performance tricks unless DateTime or your use of DateTime is actually in a hot path. So here's a really easy one. Rather than passing a string to the constructor over and over again, you can instead pass a DateTime timezone object. So you can construct that once, maybe store it as a package variable or whatever, pass the object in repeatedly. The lookup of looking up the name that you pass in each time has some overhead, so that's a way to save some time. And this one is actually the kind of optimization, if you just did it, I wouldn't complain too much because it's so simple and doesn't make the code really confusing. If you're dealing with thousands or hundreds of thousands of DateTime strings that are all in exactly the same format and you're quite sure that the format will not change, you could use a regex-based parser. What this is probably missing is an or die somewhere in here to make sure we actually got a year, month, and date out of it. But that's an okay. This is less okay than the time zone thing because I'd be like, why don't you use the format because it makes it easier. But anyway, so say you're parsing a CSV file and you know the format is the same in every column. You could do this. Regexes are always going to be faster than calling a bunch of methods. Oh, there was one more that is no longer applied. So older versions of DateTime used to use Params validate, and there was a way to disable its validation. Then I switched it to use my new module, which I talked about in Lightning Talk, Params validation compiler. The constructor got about 10, 15% faster, but it doesn't have a way to disable validation, so it's a trade-off. So that's it for stupid performance tricks. Thank you very much. So we have 10 minutes for questions, so I hope you have a lot of questions. Yes. Yeah. Okay, so the question was, on a DST transition when the clock moves back and you're adding an hour to the local time, you go from 1 a.m. to 1 a.m., and then what happens when you add another hour? Yes, it does go to 2 a.m. So yeah, it's a 25-hour day with 2 1 a.m. hours. More questions? Yes?
Can leap seconds happen anytime, or are they like 25-hour days with 1 second?
Okay, good question. So the question was, can leap seconds happen any time? So you could have could you have a 25-hour day with a leap second? You could have a 25-hour day with a leap second because time zones are made by, legislative bodies, or I guess in some countries, dictators. Do you think there's like a dictator in like some country who's just like focused on the time zones and it's just like, we will change the time zone? Who? Pope Gregory. Okay, there you go. The leap seconds only happen on June 30th and December 31st. They're announced by, now I remember, the Earth Internet, wait, is it another French thing? It's the IERS, something International Earth Rotation Service. It's not another French thing. And so they publish a bulletin, like I said, on a regular basis, and they announce whether there will be a leap second on the coming scheduled date that could have a leap second. So could you have a 25-hour day with a leap second? Well, if somebody really, really stupidly decides to put their DST transition on one of those dates, which as far as I know has not happened yet, but could happen, then yes. So I can't control for the stupidity of politicians, unfortunately. Yeah. Can you speak up a little? Okay, so he mentioned that there's a module called geolocation time zone that uses your current location to, the IANA database actually distributes some information about, oh, this doesn't look promising. What, does it return an actual name time zone or is it returning, Okay, so there's this thing which I don't know. The reason I say it doesn't look promising is I saw this A through Z. There's a military system where they name the time zones A through Z based on kind of your position in the world. Is that latitude or that's latitude? Yeah, based on your latitude or longitude. Damn it! It's an etude, and those are just pure offsets, so they're not that useful. Okay, and this might be using it. I can't tell. What was the other comment?
With respect to GMP, the reason why it's in London is because they were trying to find a solution to the longitude issue, and they needed a place to call zero, so that's where it was like.
So he said the reason that UTC is based in Greenwich is because that's where they were trying to figure out the solution to the longitude issue, which was basically a naval navigation issue, figuring out where you were. And that was the zero line, so that's also why it's the zero for UTC. That does totally make sense. Yes?
A few years ago, I was involved with some time issues in a project where you couldn't download anything from CPAN. As I recall, but durations were the important thing, at least one of the most important things. They were timed events. And so I found storing it in Epoch to be useful, and then I could just subtract two Epoch times. So Epoch, I think, has its value.
So he was saying he was involved in a project where he couldn't download stuff from time zones, and the important issue was the duration, and so he just stored epochs. And yes, that is a good point. So if all you care about is duration, say like, especially for like scientific work or something, then you can just store the epoch. But you know, this talk is really about kind of dates and times for humans. So things like calendars or events and stuff like that. I agree, but that's almost not even DateTime. You're just like counting seconds, which, you know, is totally valid use case. It's just, if you're doing that, you really don't need a module like this. Yeah, you can just have two integers and do some simple math. So.
But then I had to correlate it back to the day that it happened, and it wasn't entirely divorced.
I see.
But anyway, that was the solution I came up with for the duration, was to store epochs.
Yeah, I mean, that can work if you just store epochs. I would point out, actually, I mentioned scientific, but then if you're basing this on NTP and you get that double second, then it might actually screw up your math. So that's you know. Anyway, this is a longer discussion that we don't have time for. More questions. Larry, did you have one?
Couple things. The time coordination moved from Greenwich Mean Time to France during the Eurozone.
Say it isn't so.
And that's why it's universal time coordinated.
Oh, okay.
And the shift in the time here in the U.S. for the daylight savings time, the first one was like 23 years ago. It was a big gulf that said we want more green speeds, like $400 million if they shifted it to get more green speeds. And then most recently, Big Candy came in and said we want more time for Halloween for the trick-or-treaters. That's when they shifted the days, a few days before they shifted when.
So. We're having a debate about Halloween in the audience. He was saying that the reason that we have these French names polluting our pristine English is because at one point the French took over the timekeeping duties. I'm not really anti-France, just making a joke. And that there were shadowy, dark conspiracies involved in past DST changes involving golf and candy. You know, golf candy. Candy golf? Anyway, one more, maybe two more questions. Yeah?
Did you hear that there are politicians in New England who want to change to Atlantic time?
Did I hear that there are politicians in New England that want to change to Atlantic time? I think, you know, no, I didn't. That seems fine. People get really confused about time zones, and they're like, time zones are terrible. Everything should be on UTC, which is idiotic. The fact that I know, you know, 9 a.m. is a time when somebody will be awake and their local time is really useful. What is terrible is DST. So changing to Atlantic time, that seems fine because it kind of synchronizes your wall clock 9 to 5 or 6 to 6, however you want to think about it, roughly with, daylight and nighttime, which is generally, I think, a good thing. It's the DST stuff that's really stupid. I think it makes a lot of sense potentially for a state like Maine to want to change over to Atlantic time. So no objection. All right, Patrick's telling me I'm done. So thank you so much. If you have more questions, I will be around.